Okay, it's 1 p.m. and the only thing standing between you and lunch is Krishna.
Yeah,
So we also apologize, and also the last session before lunch, introducing Krishna G. Lodha. If you haven't seen him or if you don't know him, then I don't know what. He's the chair for this FOSS4G Asia, and he runs his own geospatial company called Rotten Grapes Private Limited. Anyone who guesses why it's called Rotten Grape will get a prize at the end. So introducing Krishna, over
yeah.
to you.
Thank you, man. Hi everyone. I hope you are having good time at FOSS4G Asia. Um, so I want to talk about something that has been that we at Rotten Grapes we were thinking for like almost more than a year, because we as a software development company specifically focusing on open source tools, we have used everything. We have used open layers, we have used leaflet, we have used geonode, postgis, every single damn thing. And at one point we realized that we have such an amazing products out there, but why the adoption, it's still not that great when it comes to institutions and all. And that's where this idea of Vista Map came into the picture. Uh, so for any institution, in order to make their geospatial portal, they have to follow certain guidelines. They like you have so for any government, or let's say any big company, they will maintain they will mention they will make something known as SDI, that is their spatial data infrastructure. What we wanted to do is that we wanted to figure out what are the latest and the greatest, uh, but at the same time still time tested products out there in open source, and how we can combine them together so that anyone can spin up a really amazing, really fast, quick and secured entire WebGIS platform altogether. And that's how the idea of Vistamap uh, has been brought up on the table by our developers. We had made Vistamap, we have scrapped Vistamap, we have again made a new version. So that is still in progress, because we are trying to figure out how we can make it much more user friendly for everyone who wants to access it. This talk is going to be more about just the tools that we have decided to pick up and how we are aligning all of those tools. And if you guys want to visit Vistamap, you can just check out vistamap.co. That's the website. And you can also see the current version, which is live at vapp.vistamap.co. It might break right now because every single day we are adding new things to it. But the idea that I want to put forward is that how you can take existing FOSS uh, universe and how you can club them together. So the problem currently that is there in the market is that the infrastructure complexity. Setting up databases, QGI servers, tile servers, they all are important if you want a faster and a scalable solution. But setting up every single thing becomes challenging. The most important thing is the workflows. We want tools where we can easily upload the data. We want tools where we can just quickly run any workflow, any analysis, and it should just spit out the data. Now, when it is spitting out the data, we also want to control whether we want that data to be available temporary, or we want that data to go in our storage. Then the most important is the scalability issue. That is something that Dr. Vivek Saxena also mentioned in the panel session discussion today, that something works in POC does not mean that it will work under pressure. So we want something that will also work under pressure and we can actually scale it. When we say scaling, we have to figure out that how we can find that sweet spot where we can scale, but we are not spending a lot. Meaning that we only scale when it's absolutely important. Otherwise, we don't pay any cost, or we pay just the bare minimum. Then the collaboration barriers. So currently, if you go to, again, this is something which has been the topic that every single conference that you go to, you will hear that there are two offices side by side. They both are working on the same project, but they cannot share the data with each other, and that happens very often. So difficulty in data sharing as well as the access control. So whenever you will meet anyone from public sector, they will say that they really want to share the data, but they just want to figure out that how they can also control the access. Now the control can be in terms of timeline, the control can be in terms of columns, or it can be in terms of extent. And the last thing is that real time processing. uh, We all know that in geospatial, the data sizes are very huge. And similarly, the functions that we execute might also take a lot of time. So we need to figure out that how we can run functions. Let's say that if you want to cap the maximum compute or maximum hardware that you can afford to that particular function, saying that okay, it's okay for me if this function takes 1 hour compared to, let's say, 30 minutes, because my spend cannot go more than x dollars. So we want that real time processing to be done, but also at our own control. And that's exactly what Vista Maps entire architecture is all about. We have a solution where you can just upload the data, it will automatically convert it into cog, it will extract all the metadata, you can change the metadata according to the ISO standard, and then you can save that data. We have real-time processing. You get notifications using WebSockets. You also do progress tracking of every single activity that you are doing, which means it is also good for auditing purposes. Interactive mapping, we have multi-layer 2D map, also 3D maps, as well as point cloud data uh, that you can that you can visualize at a warp speed. Then you have vector analysis. So the first thing that we did in our version 1 or version 0.1 was to take everything that you can do on QGIS on a web application. I think even if we are able to achieve that, that will be a really really big thing, because QGIS is without a doubt an amazing tool which has like tons and tons of functions. And not just QGIS native, you can plug the Saga functions, you can plug the Grass functions, etc., which makes it amazing. There are only two major problems. Problem one is that I want the data to be stored somewhere on the cloud and I want to access that. Problem two is that I have done something amazing and now I want to share it to my colleague, or maybe to the world. Now there are solutions like QGIS servers and all are available, but they are not very quick, or they are not very user friendly at the moment. So what we have achieved actually is that we have moved a lot of QGIS powered special operations directly into Vistamap. That way it brought down the development time a lot, because we are not reinventing the wheel, we are just putting everything that has been done by QGIS, which to begin with is already very very well optimized. And to expose the raster data, this is where a lot of debate had happened, and we decided to go ahead with T-Tiler, which is a product available by Development Seed, again a free and open source tool which is written on Fast API. T-Tiler allows you to give the reference or give the URL of any raster, which can be either on your computer or it can be stored somewhere on a cloud storage. As long as it is cloud optimized, you will be able to expose that and you will be able to use that as a web app. The beauty of T-Tiler is that you can do all kind of coloring on the front end itself by providing the color code in the URL. You can define the scalings and everything like that, which means that you are no longer dependent on your server to generate the tiles beforehand. You can just generate them on the fly. And the last thing, which was again very important, was that how we can make a secure collaboration so that granular access and control can be given. So here's the technology stack. Let me see if I can zoom it. So we are using Keycloak as a security layer, where we are using that for user management as well as role-based access. By the way, the entire Vistamaps Docker Compose file will be available on GitHub. So uh, if you guys are not, if you guys are not following me on LinkedIn, please do, because I keep posting about Vistamap over there. We are using Keycloak for user management and role-based access. Storage layer is divided into multiple sections, and there is a reason why we are doing it like that. So we all know that PostGIS is an amazing tool for vector data. Now, the way we wanted to create this Vistamap entire stack is that it has to be plug and play. For example, if you have your existing PostGIS, then you don't want to create a new PostGIS. You can just connect that PostGIS. Or let's say if you are a company who has a cluster of databases ready, you can just plug those in. So you don't have to necessarily use only what we are providing. You can just remove our PostGIS and then just put your PostGIS connections. Similarly, we are using Mini.io for our own S3 storage. But what it enabled us to do is that you can use potentially any cloud provider. You can go with AWS S3, Cloudflare R2, Blob Storage by Azure, or even Google Storage. Because we are using Min.io, every single function that we have written is an S3 compliant function, which means that if you are already a paying customer to Azure, you can just use Azure. You don't have to use our service in that. And then we are using Redis for cache and task queuing, which is again a standard tool. Again, if you have your Redis instance, hook that up. Otherwise, you can use the one that we are providing. We are using Celery for all the tasks which are going to take more than a couple of seconds. For example, the tiling service is, for example, when you upload the data, we first take your data, directly put it on our cloud storage. That way, you as a client never have to wait for anything. Once your data is in place, then we run our Celery worker to check whether that is cog or not. If it is not the cog, then we'll convert it into the cog, and then we will again ship it back to the mean IO or S3, whatever that you want to use. So that way, you only ship your data once, and all the background processing happens at our end, thanks to Celery. Similarly, whenever you run any kind of functions, we have made sure that the architecture is set up in such a way that every single function is also going to be a process in itself, which means that if you download Vista Map and if you want to create your own function, you can just copy the base file and you can just create your own function, and it's going to set in that entire infrastructure very well. So we have some base parameters that we need to give. For example, the data that you will be using in your processing has to be in obviously Vista Map. So whenever you upload a data, you get a Vista Map ID back, which then you can use to access that data. Similarly, once the process is done, then again the data goes back to either database or to your storage, and then from there it is exposed to the front end. So everything happens via Celery. Fast API kind of like acts as a middleman who just takes care of everything. So we connect Celery to Fast API, we connect all the data sets to Fast API, we also connect Keycloak to Fast API. Now, the reason why we are using Keycloak is that it's very advanced. It allows you to do SSO. It allows you to play with the roles, play with the users, etc. Now, again, if you have your own Keycloak, you don't need to use our Keycloak. You can just connect your Keycloak credentials to the environment variable, and Fast API will start using that. Which means that every single thing is removable. So it's kind of like you have a Lego set, and you can just bring either your own bricks to my Lego set, or you can just use whatever bricks that I have. Fast API takes care of JWT authentication for every single REST API as well as WebSocket management. And then we have built a front end. So the idea is that we wanted to build something that can be easily used by developers as well as by the analyst. So if you're a developer, you can just use Vistamap as your backend service. So which will take care of data sharing, data uploading, data processing, functions, etc. And you can build your own UI for that. And the way we were able to do this is because from day one, we wanted to make this product OGC API compliant. So all the layers that you are adding are exposed as an OGC API records. All the vector data that you have is exposed as an OGC API tiles and OGC API features. And all the rasters that you have are exposed as an OGC API maps. We are working in a direction where all the functions that you are going to write will be also exposed as an OGC API processes. By doing that, your entire backend will become compliant to almost all the softwares available on planet Earth. So you can use this as a backend. You can create your own front end. But if you don't want to do that, and if you are just a GIS company who want to kind of like consume the data, see your own data, and then play with that data, you can just use our own front end as well. I also have Preetham with me, who has been working on it for a year now. Preetham, can you please stand up? Yeah, so he's the lead guy who has been taking care of Vista Map, and he knows Vista Map more than I. And he was the one who said, no, we have to talk about Vista Map at this conference. So yeah, here I am. So thank you, Preetham, for all the hard work. Uh, so here is a quick overview of the backend technology. We are using PostGIS to store the database. We are using QGIS as a processing engine right now. What it means is that potentially, because we have created a base template, QGIS, bringing all the QGIS processes was a really easy thing. Let's imagine that if you have something that works with AI and you know that it's going to need some external resources. We are currently working in a scenario where all these processes based template will also allow you to spin up a new instance. Again, doesn't matter what you want to do. If you are an AWS person, if you want to use ECS, you can just spin up a new cluster You can run that particular processing in that cluster, and then again only bring the result back to your own platform. So we are working in that direction right now. Processing technologies: Celery for distributing the task, Redis for caching and message brokering, and then T-Tiler for raster tile serve. Uh, our infrastructure right now is that we are using Cloudflare R2. We are using GDAL for a lot of our internal checks, and then we have made the entire Dockerization of this tool. Front end, we have used Next.js, OpenLayers, and Keycloak. And this is how the system architecture looks like. So as a user, either you are on the map and you kind of like just request to the tile directly, or you go to our web application and then you request via Next.js and React. If you request via Next.js and React, then obviously the request will go to our own backend API, which is on in Fast API, and then from there we will just redirect to whatever you want. So for example, if you just planning to use this as a backend service, then you can just send the request to T-Tiler or to Postgres for the tile service, etc. And then from there, the requests are routed either to PostGIS database or to Cloudflare R2 storage. And then we will just cache that particular request and send you back the data. So this is how the vector analysis flow looks like. So as a user, you select the vector layer, and then you select whatever analysis that you want to do. And according to the analysis, obviously, you will also select the required stuff. Then the front end will send the request to the API. API will send the request to Celery. And then Celery will actually start the work of fetching the geometry from PostGIS. Once we have the PostGIS geometry, it will return it, and then it will again execute the algorithm. By that time, we will also send the API for a WebSocket so that you can get the idea that how much work is done. And then from WebSocket, you can actually see that on the front end. But once your execution of algorithm is done, again, the result is sent back to the Celery, which then again stores the data back in PostGIS, and it also tells the API that the task is completed, and then you get the updates via UI. So this is how the entire workflow is working. So for you, if you want to create new functions, all you have to do is you have to just figure out what you want except QGIS over here. Everything else is sorted. Everything else is been taken care. User, front end, API, Celery, PostGIS, WebSocket, everything exists. All you do is you copy the existing base file where it is also written that how do you access the Vistamap data already, or your own data already. Then you take that data, you run whatever function that you want to run, and then you just ship back the results. Uh, on the front end, I would like to talk about how we are planning to do how we are doing front end things right now. So users can treat this as their own Google Drive. They can just go to vistamap.co. They can upload the data depending upon whether you are doing vector, rasters, point clouds, geotagged photos, geotagged videos, etc. You can use this as your data storage as well. Once the data is available, you can also decide, just like Google Doc, whether you want to keep it private, whether you want to keep it public, whether you want to share it in your own organization via email IDs. Once that is done, same thing goes for the maps as well. So when you create a map, you can bring your own existing data, or you can bring the data that was shared to you, and then you can do whatever that you want to do with it. Now, in our own front end, we have 7 types of maps. So we have a single map, which takes the entire screen. Then we have a side view, and then we have a quadra view as well. So by doing that, you can also do time series comparison and all as well. By the way, a lot of these functionalities are open source, but they are open source because of the clients that we have worked with. They are the one who essentially funded these efforts. We made it, and we made it open source because they were happy with it. And yeah, thanks to people like this actually. um, yeah, so you can select whether you want to keep this private, so owner only accesses it. You can make it shared where it's so team accessible, and the next was a public, which is like available to public. Now, during this thing, one of the major problem that we wanted to solve is that how can I expose my data, or how can I expose my map with the maximum security that is possible. And when we were brainstorming about it, we had a lot of ideas. One is that you can obviously make a API token, and you can share the API token. But for example, just go to any random map box, just search for a map box interactive map on Google. You will, and once you're on the map box interactive map, just go to the network tab. You will see the key over there. Try to copy that key and try to create your own map box. 90% of the time it will work. That's how I do essentially, because I never use my own key. So that was a security flaw. I'm like, I want to create a key that will either work only on my system or the places where I want to give access to. But at the same time, think about this. If 100,000 people are using your map, every single person at one point at one map instance is going to send at least 16 requests. So you have 1.6 million requests going at one time. If you want your database, let it be your postgres or even something like redis, to kind of like validate 1.6 million requests, it's gonna break up, or either you are going to burn a lot of money. So what we figured out is that how we can reduce these calls and never go to the backend. How we can make something which once you generate a token, it will have the knowledge of only that map or only that data along with some kind of expiry. And that's where we decided to go with the pre-signed URL concept, just like how we have in AWS S3. When you want to upload a data on AWS S3, you can just generate a pre-signed URL. When you generate a URL in pre-sign, you have to give a very specific thing. What is the name of the file that you are going to upload? What is the format of that file? And how for how much time you want to keep this token alive? When you do that, the token that you get in return only has that much information. So that means it is secured. You're not exposing your company data or your user information. And at the same time, you're not making the call to the backend. So we decided to adopt that. And after doing that, like that became one of the very, very important features that we have in Vistamap. Because now essentially, even if you're running this system in on something like 8 GB RAM laptop, or like a very simple VPS, it will still work, and it will still give you very amazing results because your client is never hitting your backend anymore. So that was one of the advancement that we did. So these are some of the screenshots. So we have smart upload, which essentially means that you upload the file, we will figure out the OGC compliant metadata, and then we'll also convert that metadata into the formats that we think are important using AI. Then we have map builder, where you can bring the data, you can customize the styling, etc. We can do the styling on the fly on the front end itself, and we can run a lot of QGIS powered analytics also into the system. And here are some of the API endpoints that we have right now. Um, yeah, and that's all I think that I would like to cover. This is our deployment architecture right now. So we have a load balancer, then we have multiple fast API instances running. Then we have multiple salary instances running. And then we have externally hosted Keycloak and T-Tyler service. Which, by the way, if you use serverless, you can also host T-Tyler as a serverless system. And then we have a data tier. Every single thing in this is pluggable. So if you want more salary workers, just add those. Or if you want a single salary worker, it's up to you. Yeah, so the future roadmap of this looks like this. We are currently at a stage where all the vectors and a lot of raster analysis are also added. We are currently working on 3D visualization. Uh, what we are doing right now is that you can just dump your dem or a file which will have the z-axis information. We will convert it into meshes, tiles, everything, and then you can just visualize all the data in 3D. What we are trying to figure out is that how we can expose this data, because after being in this industry for like 7 years now, what I realize is that every single application will have a different look. Doesn't matter what application you build, every single time client is going to ask for different UI, different way of presenting things. That's where our entire focus is currently now building on that backend infra, because backend is never exposed. You can have same backend, but you can have hundreds of front ends, looking in a different way. So what we are doing right now is that how we can expose this 3D mesh data, 3D tile data also using OGC compliant services or OGC compliant formats. Then we will have some AI powered analysis. So again, Pritham is leading one of the amazing efforts where we are allowing user to not filter their data anymore by going to the filter tabs. You just talk with your data. Uh, Again, the idea over there was also that how can we do something where if someone decides that, hey, I have a chat gpt subscription, I want to use that, why should I pay to you? I'm like, okay, go ahead. If I have a olama running on my local, I want to use that. Yes, go ahead. We want to make it pluggable so that whatever subscription that you already have, you can use that. You don't need to buy a new subscription just for this one particular use case. Yeah, so this is what we are working on, and we also have our own like self-hosted Vista map which we are maintaining for some of our clients. This has been particularly helpful tool for drone industry, so people who are generating a lot of data and they want to expose this data. Not all the time your client is going to be a geospatial guy. They will not know how to open these TIFFs. They will not know how they can easily compare two TIFFs side by side to figure out how much changes have been made. And yeah, so that's all. uh, if you want to have a look at it, visit us at our booth. We have a rottengraves.tech booth. Go to vistamap.co. I think you will see a presentation slide over there or something like that. But yeah, talk to us. We'll be more than happy to set you up and work with you. That's all from my side. Thank you. I'm open for questions now. Thank you.
That was a lot. I hope we are ready for some questions. Anybody got any questions?
Wait, please.
Yeah, we'll just repeat the question.
Vista map is on Cloudflare. Am I correct?
No, only the
Hosting.
storage.
We are hosting on the. That's what your slide says.
Sorry.
Vista map is an independent cloud, or you are hosting some other services, cloud services.
We are using cloud. So for example,
Yeah.
we are using Cloudflare R2 for our
Yes.
storage.
Yeah.
So that is about us. But the way it is made is that you can host it on wherever you want. If you even, for example, we were working with the clients where uh, they don't use any cloud services and they don't want to use any cloud services. They're like, because we are working with like 200 300 TB worth of data, it will not make sense for us to have cloud service. We'll just get our own hardware. So we made it in such a way that that can also work. So you just install mean.io, which is again an open source product, to make it S3 compliant.
Is Vista your JS? Is it OS independent?
Yeah, there is a Docker file. So you run it wherever you want to run it. There's a Docker file for that. And that Docker file has everything. And an environment variable file, you just mention what you don't want to use from our side. So for example, if you have your own PostGIS, then in the Docker file, in the environment file, you just give that PostGIS connection. That's all.
Okay. Any more questions from anyone?
We are trying to be the one of the companies from India who has this, entire SDI open source available. So any love from you guys would be helpful for us. So please meet us. Please give us the feedback that what we should add, what we should remove, or how we can make the life easier. My hope is that in the next FOSS4G, when we all meet, we can actually give you the entire demo. So yeah, that's the idea.
Okay. Thanks everyone for the session. The lunch is now up. I hope. Yeah, I see some of you guys are hungry. Okay, so we'll meet up after lunch. Yeah. Thank you everyone.